leaving speed of the ball from the floor is around 7. 30% of energy is lost in the collision. Okay, we're given here the speed of the ball right before colliding with the floor, which is 8 meters per second initial velocity. Okay, and this is the mass. From these two things, we can determine the kinetic energy of the object right before hitting the floor. Kinetic energy is 1/2 mv square, mass multiplied with square of velocity, speed.
Yes.
This is the energy in total right before total energy. We assume that right before hitting the floor, the potential energy mgh is 0 because it is very close to the ground, and therefore h here is 0, and therefore we do not care about the gravitational potential energy. Okay, the next thing, 30% of energy is lost during the collision. So the energy after the collision, the final energy or energy leaving the surface is 70%. 70% of that kinetic energy initial. Okay, and of course, right leaving the floor, the height is still 0, and the potential energy, gravitational potential energy, is still 0. 0.7, 70% of this thing. Let's calculate this thing.
Yes.
The kinetic energy initial. Calculate it. The mass is 2.8 grams. We need to convert into kilogram here, and then the speed is 8. Square it, huh? Now the energy.
Yes.
1/2 means 0.5. Then the speed, the mass divided times 10 to the power of -3. This is the speed, the mass multiplied with the speed, 8 square. There. Oops, something wrong with. I accidentally put a 0 there. 0.5 times 2.8 times 10 to the power -3. -3 here, and then times 8 square, which is 64. This is the energy, 0.0896. 896 joule. Okay, that's the initial energy, 0.896 multiplying with 70%. 0.06272. 0.06272 joule. I do not do the rounding for the medium step here, but do only one time rounding at the end, the last step. Okay, this leaving energy is actually only the kinetic energy 1/2 mv leaving here square. Again, the height from the surface is also 0. Just right the moment, the instant that it start leaving the floor. Okay, and therefore, just solve this simple equation, we can find the leaving speed. Leaving speed is 2 times of its energy, 0.06272, divided by the mass, and then take the square root. Okay, the mass is 2.8 gram, 10 to the -3, convert to kilogram. Okay, you got it?
Yep.
Please take out the calculator and calculate this speed. I would like you to do so. Do some calculation, not depending on my or doing all the work.
Yeah.
Times 0.06272, then divided by 2.8 times 10 to the power -3.
2.8.
Yeah. And after taking this value, I will need to take the square root of this value. Square root of that thing, 44.8. The answer, you see, 6.69.
69.
Yeah, which is
Close.
very close to 7.
Round to 7.
Yeah,
Yep.
44.8 rounded to 6.7 meter per second. So that is the solution of the first question, around 7 meter per second. And of course, the number of significant figures is 2. 2.8 for the mass, 2 sig fig, and 8.0, 2 significant figures. And therefore,
Yes.
I rounded to
Yes.
here, 6.7. Question B. The ball strikes the wall as it reaches the highest point on its motion. Determine the horizontal distance between the ballast point and the wall. Horizontal distance, strike the wall, just reaches the highest point. Okay. This is a projectile motion problems. Do you remember that thing
Yep.
like studying in the ICSE? Yeah, like this.
Yes, I
Yeah,
still
yeah,
remember.
Yeah. This is the highest point. It collides with the wall right at the highest point.
Uh-huh.
Determine horizontal distance. The question is this. Let me change the red color. Horizontal distance. This one. X.
So I'll find
Yeah.
the time
To
it takes
find that
and
thing,
take
the
to
X.
do that.
We need to find the horizontal velocity Vx and then multiply with the time it flies from leaving the ground to the colliding with the wall. Find these two things.
Uh-huh.
Find these two things, horizontal speed and time. We will get the answer, the horizontal distance. Okay. Firstly, the horizontal velocity Vx is very simple to find, right?
Yes, we got
How
65
do we find
degrees.
The
So,
initial speed when leaving the ground multiply with what?
We got 6.
With
So,
cosine
6.7.
cosine of 65 degrees.
Yeah.
Okay, this is the velocity. Let me make it taller, steeper. This is the speed, velocity. Sorry, the angle is 65 degrees. There. This is the horizontal component, Vx. Yeah.
Yep.
So that's why it is times the cosine 65 degrees. Okay. This is 6.7. We calculate the value also. Cosine 65.
Yep. 6.7.
Is it degree region here? I don't know. Cosine 65. Let's check that. It is supposed to be greater than 1/2. Wrong. This is like radian. I need to convert into degree somewhere. Oh, here. Degree. Cosine 65. No, it's wrong. Cosine 65. Wrong again. Let me use another calculator.
It's 2.83.
Can you say again, please?
2.83.
2.83 meter per second horizontal speed. Okay. Now the time it flies from the floor to the wall. How do we find that time?
We have horizontal. We have the starting horizontal speed. What do we have next? We have wait, actually, let's. If I would find time, I would do the vertical thing first. We'll do that. Like find the vertical the vertical velocity and then the vertical velocity. Then do all the things to find the time. So that.
Actually, this term is determined by the equation for the vertical component velocity Vy. It is the initial Uy, which is this vertical vector that I am drawing here.
Yes.
Vy initial. Then plus gt, where g here gravitational acceleration is minus 9.8. The minus sign indicates that the velocity decreases when the object flies up.
Yes. So final velocity is 0, and then starting is
from this equation,
65.
Vy equal to Vy initial minus 9.8 times t. We can determine this time. The time is the Vy on the top, which is 0. This one is 0. Minus Vy initial, which is V times sine of the angle 65 degree. And then we divide G, which is minus 9.8. Okay, so that the minus on the top and the bottom divide each other. We have a positive time. Okay,
We have 0.619
second. Okay.
Yes.
So the distance of the answer to this question B, horizontal speed multiplied with the time. Horizontal speed is 2.83. The time is 0.619. We get the answer. 2.83 times 0.619, 1.75 meter. 1.75 meter horizontal distance. Okay. Revision village. I'm trying to find the answer, the mark scheme to check it, but my account has drained out. It's not valid anymore.
Let me check it.
Okay. You have a revision village account.
I do.
And round to two significant figures is 1.8.
Wait me a minute.
Calculate the time again.
Wait, I'm looking for it right now. The correct answer is 1.8.
The mark scheme says 1.8.
Yep. It is 1.8.
So this solution is correct. Okay, that is the question B, huh? Let's try finishing this question C.
Okay.
The ball collide elastically with the wall with the time of contact during the collision is 0.04 seconds. Calculate the average horizontal force exerted by the wall or by the ball during the collision. Okay.
Same to last.
You can use the one of the two methods for the first problem here. Just use the first one.
I use the second one.
The first one or the second one doesn't matter. Any method works. Okay. We're given the time, the elastically. Okay. The key point that most students actually do not know how to solve this problem. The key point is this thing: elastic collision. Collide elastically.
Means that
which means
the energy conserved. The energy is not lost during the process.
And how about the velocity? How do we know the velocity of the object after the collision?
It says the collide and then since
collision. There are two ways that a collision is defined to be elastic. One of the two ways. The first way is that the kinetic energy before collision, kinetic energy before, equal to the kinetic energy after the collision, final. Okay, that's the second definition. The second definition is the velocity of approach is equal to the velocity of leaving. The velocity of approach, if the problem is the two objects, like a ball moving toward another ball, V1 and U1 and U2, U1 and U2, the velocity approach is defined by U1 minus U2. But the velocity of leaving is V2 minus V1, meaning that you need to switch the order of the two terms. Okay. Anyway, in our case, the ball colliding with the wall, which is vertical, and therefore the U2 here of the wall is 0. And therefore, the second definition here of the elastic collision means that the velocity of the ball after bouncing off the wall will be the same in magnitude. The same, this is u, this is minus u, the same in magnitude but opposite direction to the velocity of the ball right before hitting the wall. Okay, and that velocity when it hits the floor is the Vx only, because the vertical component is 0. This is the maximum point, maximum height. Okay, therefore the velocity of the ball before hitting the floor is this Vx that we calculated already in question B, which is this value 2.83, huh?
2.3, yes.
Yeah, 2.83, and therefore the velocity after leaving the wall will be the same but opposite direction, huh? Meter per second as well.
Yes.
Meter per second, leftward in the opposite direction, and this is rightward, hitting the floor. Okay. the question is finding the force, and we can use the definition, the Newton's second law, mass multiplied with acceleration. Okay, the mass of the ball, what is that value? I forgot. 2.8 times 10 to the power negative 3, huh? 2.8 grams. Okay, 2.8 gram times 10 to the negative 3. Acceleration is, find the velocity 2.83, which is a negative because it is in the opposite direction, leftward. Okay, so I can put a negative sign here indicating it is opposite. Okay, and then minus initial velocity, which is the same value. Okay, divided by the time of collision, which is 0.04 second.
Yes.
0.04 second. So the point is that we need to remember the minus sign, because without a minus sign, the calculation is wrong. Is wrong because this is the change in velocity, which is a vector subtraction, vector difference. This is final velocity v2, and this is the initial velocity v1, which is the same in magnitude. So v2 minus v1, we need to add with v2 with the opposite of v1, and therefore the result is a long vector like this, meaning that this is a bigger number compared to 2.83. Okay.
Yes.
And the answer, the force is, can you use the calculator to find this value and then check the mass scheme?
We got, so basically we got, I'm not sure if this is correct, but we got minus 0.39.
0.39 Newton. Okay, do you have the mass scheme there?
Okay, let me check the mark scheme real quick. 0.4.
Yeah, this is 0.39, write it. 0.4.
Yep, 0.4.
It doesn't matter the negative sign. Negative sign just indicate that the force is leftward
Yes.
in the same direction with
It's
acceleration.
opposite. Yeah, it's opposite.
Same
That's why.
direction with acceleration.
Okay, so it is correct.